A rectangular solid has length 20 centimeters, width 5 centimeters, and height 10 centimeters. How many of these rectangular solids, when combined, have a volume of 1 cubic meter? And they tell us that 1 meter is equal to 100 centimeters. So there's a couple of ways we can think about it. So let's try to just visualize this rectangular solid. So it has a length of 20 centimeters. So it has a length of 20 centimeters. So that is 20 centimeters right over there. Has a width of 5 centimeters. So that is 5 centimeters right over. Actually, let me make it a little bit. I'll try to draw it a little bit closer to scale. So it has a width of 5 centimeters. 5 centimeters. And it has a height of 10 centimeters. It has a height of 10 centimeters. So that looks like about 10 centimeters right over there. So that is 10 centimeters. And so let me complete the drawing here. So that's 5 centimeters, and that is 20 centimeters, 20 centimeters, just like that. This is 10 centimeters, and then this is, I'm just drawing the whole thing. If you were actually doing this on the standardized test, you wouldn't necessarily take the time to draw it this neatly. But one way to think about it is, well, what's the volume of this thing? And then just think about, well, what's the volume of a cubic meter in terms of cubic centimeters? So let's calculate the volume here. So the volume here is going to be equal to 10 centimeters times 5 centimeters times 5 centimeters times 20 centimeters times 20 centimeters. And what is that going to get us? That's going to get us 10 times 5 is 50 times 20 is 1,000. It's 1,000. And our units now are cubic centimeters. Centimeters times centimeters times centimeters, cubic centimeters. So you could take 1,000 of these little cubic centimeters and fit it into this larger rectangular solid. Now, how many cubic centimeters are there in a cubic meter? Well, in a cubic meter, you have a situation, a cubic meter. Let me draw a cube here, and I'm not drawing it to scale relative to the other figure. A cubic meter, so this is my cubic meter. I'm drawing it as close to a cube as I can draw it. So it's going to be 100 centimeters. It's a meter by a meter by a meter, but a meter is 100 centimeters. So it's 100 centimeters wide, 100 centimeters long, and 100 centimeters high. So what's the volume of this in centimeters? Well, the volume here is going to be 100 times 100 times 100 centimeters to the third power, or centimeters cubed. It's going to be 100 times 100 times 100 cubic centimeters. Or this is going to be 1 with 6 zeros, 2 zeros, another 2 zeros, and another 2 zeros. So it's going to be 1 million cubic centimeters. So if this is 1,000 cubic centimeters and this is 1,000,000 cubic centimeters, well, how many of these can you fit into this? Well, this has 1,000 times the volume of this. 1,000,000 is 1,000 times 1,000. So the answer right over here, is 1,000. 1,000 of these would fit into this. Now, another way that you could have approached this is you could draw a cubic meter right over here. It's 100 centimeters by 100 centimeters by 100 centimeters. And just think about how many of these you can stack in the different dimensions. So for example, if this is 5 centimeters wide, you could stack 20 going in this dimension. So you could do 20. I'm just going to draw it really. I'm not necessarily drawing exactly 20, but you could put 20 in this direction. You could put 20 in this direction. 100 centimeters divided by 5 centimeters. You could do 20 in this direction. And what about this direction? Well, this is 20 centimeters long. This is 100 centimeters long. So you could do 5. 1, 2, 3, 4, 5. So you could do 5 in this direction. And then finally, how many can you do? How many can you stack up? Well, this is 10 centimeters high. This is 10 centimeters high. This is 100 centimeters high. So you could do 10 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Well, you get the idea. So you could stack 10 in that direction. So how many could you fit? 10 times 20 times 5. 10 times 20 times 5 is equal to 1,000. So you can think about it either way.